require really critical analytical thinking to make sure you know what they're going through. Discuss. A little harder than the one I did. Which I'm sure you don't. Twice, yes. Yes, you are on the right track if you're doing it twice. As x goes to 0 from the positive side, cosine goes to 1, right? That's important, but is it a little more than 1 or a little less than 1? At 0, cosine is just a little less than 1. So this, is it a small positive number or a small negative number? Which one's bigger, negative 1 or cosine? Negative 1 is bigger. So it's a small number and the negative is bigger. This is 1 over small negatives, which does not go to infinity. It goes to negative infinity. That first term is negative, approaching negative infinity. 1 over x goes to 1 over small positives. That's infinity. So the form I'm getting here is negative infinity minus infinity. Is that I don't know? It is not I don't know. Negative huge numbers and another negative huge number is a negative huge number. This answer is negative infinity. It is not indeterminate. All right? So you got to, I mean, that first part is really meticulous, slow work to make sure you don't waste your time doing the stuff when it's not appropriate, right? It's not indeterminate. This one, small change now. 1 over negative 1 plus cosine of x it's the same, so that obviously is negative infinity. 1 over x goes to infinity, that's fine. But what makes it different now is that now it's negative infinity plus infinity. This is the change. That rearranged is the same as infinity minus infinity, and so is this one indeterminate. It is. Okay, that one is indeterminate. So we go about our quotient process. It's going to be ugly for a while, but then it'll clear up and it'll all be beautiful. So x minus 1 plus cosine of x over x times negative 1 plus cosine of x is an indeterminate fraction form. You don't have to prove that. Okay? By L'Hopital's rule, 1 minus sine of x, and the denominator, I guess, is going to take the product rule. Remember on L'Hopital, you're not using the quotient rule for your derivatives, you're doing the derivative of the top compared to the derivative of the bottom. It's very common for all Calc 1 students to think, so I do the quotient rule. No, L'Hopital is a different kind of idea, separate derivatives. So, derivative on the first stays the same, derivative of the second. plus second stays the same. Derivative of the first looks like that. 1 minus sine of x goes to, oh, I'd like to, Pete. It doesn't go twice, does it? 1 minus sine of x goes to 1 minus 0 or 1. So at least it's not going to be indeterminate. That's good. Question is, what's the bottom now? It's 1 over positive small or negative small? I'm going to need more room. Okay, sorry. You see where I'm at? The top is 1. X goes to positive small or negative small? Go for the positive side. What about negative sine of x? Positive small or negative small? What does sine go to from the positive side? 0. Positively or negatively? Positively. Then throw the negative, so 0 from the negative side. Small negative. Okay. What about this guy? What do we say this goes to? Negative small or positive small? Negative small and 1. So overall we get tiny negative plus tiny negative. This is 1 over tiny negative, so this approaches negative infinity. That one is as ugly as you'll see. You won't see anything that ugly in the homework for the most part, I think. Okay, you with me? Okay. Imagine then a second indeterminate form. What if you took a super duper huge number times a super duper tiny number? What would the result come out to be? And of course it would depend. It would depend on how super huge and how super small, right? This is an indeterminate form number 4. Super big times super small is indeterminate. The rates at which super big and super small happen matter. Same will go. You make a ratio. You must make a ratio of the terms, and then you use L'Hopital, but you never use L'Hopital here. This should be T, by the way, not X. T. Okay, so sine of T. As T goes to 0, what does sine of T go to? 0, small, positive. What about log? As T goes to 0, it helps me to think graphically. Here's the log graph, yeah? As T goes to 0, what do the Y values approach? Negative infinity. Okay? Well, that is an indeterminate form. Tiny, small, tiny, tiny, tiny times large, large, large. Doesn't matter that it's negative. It still don't know. So you're going to use L'Hopital's eventually, but first we must make it a ratio. It's your choice what to put in the denominator, but I think it'll be easier if I put sine in the denominator like that. So, log derivative, what is it? 1 over t. What about cosecant derivative? Do you remember it? Negative cosecant cotangent. Okay? Before I try to evaluate this, it's crucial to clean up as you go. You're going to get sometimes some complicated stuff. So let's rework this before I try and evaluate the limit. For example, I could take these trig expressions and use their reciprocals and put them in the numerator. For example, cosecant in the denominator is the same as sine in the numerator. Negative sine t tangent t in the numerator over that 1 over t's t. What about that? Evaluate it now, and what do I get in the top? 0 in the bottom, or in the denominator. 0, so what does that mean? L'Hopital again. Negative sine t, tangent t goes to 0. T goes to 0. 0 to 0 is indeterminate. And therefore, by L'Hopital, I can compare the derivatives. What's the derivative of the numerator? Please. First stays the same. What's the derivative of tangent? Secant squared t. Second stays the same. What's the derivative of negative sine t? Negative cosine t. Over the denominator, which is just 1. So thankfully, it's obvious we're going to only have to do this time, and we're going to be done. As t goes to 0, what does sine go to? 0. On the negative side. What about secant? Where does secant go to? Secant is 1 over cosine. What does cosine go to at 0? 1, so that's 1. What does tangent go to? Tangent of 0 is 0. And cosine, we said, goes to 1, so with a negative. So overall, our limit is? Which is to say that the sine won. In the competition between small sine and infinite natural log, the sine term won. All right? Try this one on your own. It's a lot easier. And we'll be done. While you're doing that, I'm going to give back tests. All right. At the very least, we'll go over the first page. If you did that by the book, you might end up doing about 3 local calls, maybe 4. If you just used end behavior, you could probably do it without the theme. Local calls, without private.
You do it like 3 after we do it after we do it the first time like this, and when we have to keep, do we have to keep going back?
No, you don't have to keep showing it. Actually, you should, yes. I'm okay, actually, especially if there's a multiple choice. Just right here, you see, I know we have to mention it. I can give it. But by the book, if you're going to use local call, then it really should go. Set by your
Sure. What do you got?
if you unless you're you just set up
You guys yeah.
All right. There we go. Just a second. Sorry. I hope that I'll definitely go over 1 page, maybe 2. I don't know how many questions you have on the homework, but I at least did want to go over 1 page of the test. The curve the curve you see, the percent you see is a curved score. It's not your true percentage, obviously. You're welcome.
This was like the last minute change for me, because I was like second guessing myself, and I got it early, so it's cool. It's cool. Like all together.
So we're all obviously.
Oh, my bad. Sorry. Okie dokie. So, there you go. I would like to go over a few of these, and if you have questions about others, let me know. So, number one, so this goes to AP's ability to make a rather simple concept a little harder. From past experience, having taken data, if I give you the problem y equals x to the natural log of x, find dy dx, going from memory, I would say the success rate was probably about 80%. If I phrase the question this way, take the derivative of x to the natural log of x, the success rate drops to about 30%. Now then, what makes this harder is that you would normally here say, I know that I want to bring this down, and I do that by taking the log of both sides. Here, there are no both sides. So the question then is, well, what do I do? I had people saying, I don't know, I just took a guess. If the problem is that you would like there to be both sides, then change it to a problem where there are both sides. Your first thing you should do is say, I'm going to rewrite this so there are two sides so that I can take the derivative of both sides. Then you do your logarithmic differentiation. Now then, you might say, Mr. Rickman, you're such a jerk, you chose the form that's 30%, to which I would respond, that is mean, and if only I would have given you some warning. Oh wait, I did. On the review, before the test, I said on logarithmic differentiation, make sure you review your notes. In cases where there aren't two sides, you need to be aware what to do. I told you ahead of time, subtly maybe, but I told you ahead of time, you need to know how to do it. And some people taught that note and that was cool, but some people just say whatever, blah, blah, blah. On the reviews, you need to do more than just say, where's the practice problems, I'll do those. I write things for a reason. I don't take an hour and a half to write the crap I do for no reason. They're there for a reason. Read it. Okay? Studying for math is not just practicing problems only as much as I wish it was. It's more than that at the higher level. This one, for the most part, things went well. If you are one of those people that does these problems by saying odd plus odd is, that's whatever. I'm not going to focus myself on you. I didn't teach you that. That's nonsense. That's garbage math. I'm not going to even discuss that. That's nonsense. Okay. For those of you who did the problem the proper way, let me tell you where your error was. This is the hardest one. When you determine even, odd, or neither, your goal is to say what happens when you put in a negative. That's how you determine what goes on the right way. So let's go through this. G is odd. What happens then when you put a negative into G? You get out a negative. Okay, so that's step one. Now this is the part that was kind of kooky. Well, what does that mean? F, just think of this like a U or an X. F of negative whatever is the same as negative F of that. Okay, so this is negative F of G. Well, If when you put in a negative, it's the same as the opposite, that means that is odd. So that was odd, the second one was odd, the last one was even. Okay? This, I was happy with how many people got this right because there were quite a few strong distractors here. And most people chose well, but the idea is this, if I want distance, then it's about absolute value. And then the second question, the second concept is, do I use the initial or not? So there were meant to be two concepts here. Distance is if you do this, and that's B, okay? If you chose C, it's because you said 2 plus the distance, despite the fact that we had a conniption fit the week before saying don't use the initial when you shouldn't. This is not true. You don't need the initial. I don't care where I started. If I want to know how far you went, I don't care. This one was meant to get at, did you think distance was this? If you integrated V rather than absolute value of V, in other words, you found the displacement, you might have chosen V. This one was displacement plus initial condition. That's doubly wrong. And this, I just made crap up there. I don't know. Okay, so that's that. This, okay, I'm gonna, if I have a heart attack someday, hopefully when you're graduated, you can guarantee it'll be happening when I go over a test with the calculus class. Because I'm going to have a heart attack someday. Okay? If you see area or volume, your answer better be positive. And I don't mean your answer is positive because you put crap work down, saw the negative, and erased it. I mean, you took steps to make it positive, and it came out positive because of those steps. If, for example, you did this, area under the curve, here I go, 0 to 2 pi, negative 1 plus cosine of x. Now that should be negative. If you put that in your calculator, that's negative 6.283. Now if you gave me that, it was minus 2 out of 3. 2 because you set it up poorly, although the answer for what you set up was correct. That does yield negative 0.6283. The one that ticked me whatever, is the people that set it up wrong, but magically came out right. For you, I took off 3. And if I could have taken off more, I would have. Because you're wrong, your work was wrong, but your answer was right, and you didn't care. You lied to me. You lied to me. You're a bad mathematician and a liar. Okay? That's offensive. You know doggone well it shouldn't be negative. If you erased it, you know it's not supposed to be negative. Why didn't you do something about it? I freaking young. All right. So, don't be a liar. Either be a mad mathematician or a liar, but not both. Or better be a great mathematician that's honest. And super. Okay. The volume here, this one I cut you slack on. So this actually, what this should have been is some kind of step to make it positive. My preference is if you just always use upper minus lower. I know it's tedious, but if you do upper minus lower, that can't be negative. It can't be. Upper is more than lower. It will always be positive. Every time. Okay? It cannot fail you. So if you would just get in that habit, I know it's extra writing, you will always be correct. Furthermore, you'll be correct when you don't know what the graph is, which is really important because you're going to get to calculus in college where you don't have your graph and calculator. You're going to have to know what the heck you're doing without the calculator staring you in the face. Okay? This one was the same deal. If you failed to take steps to make this positive, then you will get negative volume because these heights to these cylinders, if you just use straight up y and said volume is 2 pi x negative 1 plus cosine of x, that's negative. That's coming out negative, no doubt about it, because you have positive radii and negative heights. That comes out to a negative value. Do something about it. Okay? This one was a good one. Now, you're going to have 6 free response questions. And in order to get a 5, you need to average 6 out of 9 on the AP test. Some of them will be harder than others. It's not like you consistently get 6s. Sometimes you just kill it, get a 9. Sometimes this is what I would call a tough one. And here my hope would be that you make at least 4 or more. Okay? This is a hard one, and it's meant to give you practice. So when you take that AP test, you think, man, I've done those hard ones. I've worked through it. I've scratched for points. Okay? Use the definition of the derivative. This is also something I tried to prepare you for in the review. I've never given the reviews before this year, by the way. I just said, go for it. I tried to say you need to review one-sided limits to prove a derivative doesn't exist, and some people had it in their mind and obviously knew it, but some people not so much. Just so we're clear, this isn't the definition of the derivative. I defy you to find a calc book in the world that shows that that's the definition. That's not the definition of the derivative. The definition of the derivative at 0 says you find the slope between 2 points, say I'll call it x and 0, draw the slope between them, and take the points closer and closer and closer together to see what the slope approaches as the 2 points become 1. That's the definition of the derivative. That's shorthand notation for a multiple choice question. So you're way off there. Okay? If you say the limit as x goes to 0 from the left, then you're on the right track. That side was linear, so you could probably be expected to find the actual numerical value to that side. The derivative over there was, what, 2/3? Okay. The right side is the part that some of you were definitely knew what to do, but you kind of got hung up on the right side. You're not expected to actually know what the derivative is over here. You're expected that you would create an x over here, draw the slopes between them, and just make some kind of conclusion that it's not 2/3. That's all you have to really say is, you know it's not 2/3. If you draw the slopes on the right side, I just said negative. That I know. I know that's true. I don't know what it is numerically, but it's not 2/3. After that, you conclude because those are different, or just say they're different, the derivative doesn't exist. That's the idea. If they say definition of derivative, you should be writing a difference quotient or a slope and taking a limit. Yes, ma'am? A good question. One was for the difference quotient. They worded it as this. 1 point was for sets up a difference quotient. Now that, I used the alternate form. You could have used the first definition, but not this. Okay, I had at least one person do this. Is that the definition of the derivative at 0? No, that's the derivative at all x, okay? So if you went this way, you had to say f of 0 specifically. Oops, that should have been there. That, if you use the first definition, it would have been 0 plus some point h away and finding the slope and taking h to 0. So I think the alternate's easy. Sorry, I stopped in the middle of my explanation. So 1 point was for sets up the difference quotient. 1 point was for finding the one-sided limits and concluding the derivative doesn't exist because they're different. So one-sided, not the same. Okay. If you didn't do A, then you were out of B. You couldn't get that second point if you didn't do difference quotients. B I really liked, and B and C I felt like it evaluated if you really knew calculus well and could think on your feet. I think you'll agree that you've never done that problem before. Me either. Okay, that's going to happen on the AP test. You're going to have to think on your feet, and that's good. That's light. The average rate of change on the interval. So my hope is that you do this. I'm not quite sure what this is getting at, but I know how to find average rate of change. Don't focus on what you can't do. Don't say, oh. Say what can you do. Can you tell me what the average rate of change is between 2 points? Because if you wrote this, you just earned a point. Okay? Expresses average rate of change, somewhat. Now, if this is going to be 0, now is the actual nitty-gritty of it. If this is going to be 0, that implies that the top is 0, which means you're looking for f of 6 equaling f of a. Now, what does that mean? Well, it means you're looking for points on the curve that have the same y value as that point. If I draw here, how many points have the same y value? 2. Okay? If I use an a here and draw the slope between those two, the slope is 0. If I use an a here and draw the slope between those two, 0. So your idea was you're supposed to find, identify that this would only be true, secant slope would be 0 only if you found other points with the same y value in there. The points there were for 1 point for expresses average rate of change, and 1 point for answers 2 values of A with solid reason. Okay. I like C. It was obvious on a few people that they just weren't quite, they didn't quite get the meaning of the question here, which is understandable. It's pretty freaky. Is there a value A between -4 and 6? So I'm not using -4 and 6. I'm looking to create some A in here. A here, or A here, or A here. Some A here in conjunction with this point so that the mean value theorem would give a result of 1/3. Okay, that's the question. Well, I wasn't quite sure, but I thought, well, if I'm looking for a slope of 1/3, then I need to have this point and some other that gives us point of 1/3. What other point on the curve would give you a slope of 1/3? Down 1/3, it takes you to this. If you use that as the endpoint and that interval, then you've got this little mean value theorem situation of 1/3. And that's what the point was. What left endpoint could you use to get a mean value theorem of 1/3? So you'd say something like, first of all, answer the question. I had people had the right idea, and I could definitely see they knew what they were doing, but they never really came out and said, is there a value of A? The first thing you should probably do is say, yeah, A is something like, yes. If A equals 3, then the function is continuous and differentiable on the interval 3 to 6. Okay, I understand there's a sharp turn there, but on the subinterval 3 to 6, you're cool, right? So it is continuous and differentiable on the 3 to 6. So by mean value theorem, there is an f prime, let's see, blah, blah, blah. You get the idea. F at 6 plus f at 3. Okay. This one, I actually got an 8 on this problem because I went too fast. And some of you top end people also maybe missed a point here. I saw G as concave up, so I thought, well, I need the second derivative of G, yeah? I said, so I went straight to G double. G double is what relationship to F? F prime. I just lost a point there. They won't allow you, apparently in their rubric, they won't allow you to make that big a jump. They wanted to see, the first point was for connecting, you don't go straight to the second derivative without first passing through the first derivative. They expect you to show G prime is F, and then G double is F prime. And if you fail to show that in between step, you lost a point. So G double is F. G is concave up if G double is, which is F prime, which is the slope of F, positive. This happens on, and then look at the graph to see where the slope is positive, but the function's increasing. It's here. So a lot of people gave away a point. They said -4 to 2. Yes or no? Yeah, they looked at a y value all of a sudden. Remember, it's the x value. It's negative 4 to 0 and 3 to 6. That kept at least one student from getting a 9. They just made this, they rocked all this high level stuff. And then on this interval, they said negative 4 to 2. That's too bad. It's negative 4 to 0 and 3 to 6. Okay? Does that make sense? Yes, ma'am.
Why isn't it like G prime equals f of x minus f of 0?
That's a good question. I saw that a couple times. So let's go here. I'm gonna. So let me say this because again, a lot of smart people thought this. I had a couple people say G prime is f minus f at 0, and I'll give you a reason why that's not true. Say you didn't do anything up to this side. By fundamental theorem, you take the antiderivative of f, which we calculus you typically call capital F. Okay, capital F at x minus capital F at 0. That's another way of writing this, antiderivative at upper minus lower, right? You with me? Now imagine if you took the derivative of this. Derivative of this, that's the derivative of the antiderivative, and that is f. But this, that's a constant. And so when you take the derivative of that, that goes away, and it's just this.
Okay.
Does that make sense?
Yes.
Okay. See that?
What is the inclusion?
The inclusion of the endpoints, they don't grade for it. They all take it either way. I wasn't quite sure what to think about that. Good point. You don't have to have concavity, by the way. You can have neither concave up or down at a point if the second derivative is 0. So they don't look at that. Okay. I think I'll do the second page tomorrow and maybe get a question or two on the homework. So can I get those back, please? And I'll go. Thank you. How are you doing this?
Old Jersey Square
And they're like, they're all singing. It's not that hard. They don't hear it.
I know. But it's just, it makes me like rude. It's like when I use psychology, like having songs to it's like, no, you ruined it. Now I can't listen to it without thinking of, oh yeah, and he's like Viagra, you know, so like, it's an issue. Yeah.
Thank you. What questions do I have? Thank you.
Yeah, I got a lot of questions.
Okay, I'm sorry, number, did you say 1? 1 and 24. Yes. Oh, sorry. 13. This is off 90. Somebody say 4. Okay. Okie dokie, here we go. Here. I'm out of it.
Yes.
One's not replaced, is it?
No.
Okay. What kind of problem is this? In case you ever become a calculus teacher. No, it's a related rate problem. Wait, next year's H. Okay. A cone's dimensions is shown. Water, depth of H. Water distribution.
Good morning, Dublin Jaguars. Please rise for the salute. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All students, 8th graders and last name start with G through L will be required in counseling today during 7th hour in the auditorium. Tomorrow's last name
All students period for curriculum Italia and for boys and girls all-star volleyball only today.
For students interested in AT computer science, there will be a short informational meeting, computer lab, ME202 during the 7th hour today. All are
Ready? anyone interested in signing up for AP Art, including 2D drawing and 3D art, there will be a mandatory informational meeting
Hey,
today in Explorer Room.
The key is to use proportions to get it down to 2 variables.
If it's the right fit for you. If you currently do not have either
Look at
art,
this,
super
you know, it's,
Craft has
for the overall, it's
Course registration material will be
two-
collected this
a
Thursday,
1 to
March
2
3rd,
ratio in the
7 hours.
radius to the
Return
height.
work for your first period teach on Thursday for 7th hour and bring your course
So if the
selection.
radius to height ratio is 1 to 2,
If you're
I can
signing
say
up for an
that,
AP class, you also need to complete an AP contract, which can be
But the radius is 1/2
from
the
county
height.
office.
The Century Grove Golf Team practice for today canceled again due to the snow we had at the end of last week.
Would you like a wider coverage?
Pi over 12 H3 for your volume equation.
Come to Chipotle and Belmont today.
Does that make sense?
Encourage and support your track team. Be there or feel a large burrito shaped hole in your leg.
Have you picked up the trendy Colterra bracelets at lunch? Get yours for $5 outside the lunchroom to support Latin American artisans and enter to win a Starbucks gift card.
Senior high students, the college drive class will be in Miss Weber's room, E114, from 1:45 to 3:15 today.
All boys playing volleyball this season, trials will be March 5th from 5:30 to 7:30. There's an open gym for all boys interested in playing this season tomorrow from 5 to 7 in the main gym. If you have not turned in your forms to Miss D, please do that ASAP.
Dazzling Jet, the female student athlete for February is Kylie Bridges. Kylie Bridges has been a key contributor this season, helping us to a second place finish in the top 4 in Jessica League and a 17-6 overall record. Her three-point shooting ability made her a threat every possession, and her timing to block shots makes her an intimidating defender. She was 10th and 4A in the state with 43 made three-pointers and 14th in blocks with 39 on the season. Kylie is everything you want in a teammate. Positive, dependable, and selfless. Kylie was nominated by Coach Olson.
The male student athlete of the month for February is Daniel Brady. Throughout the season, Dan has continued to improve on the basketball court in terms of his statistics during games, but also as a leader and as a source of energy for our team. He is a threat from inside or outside and has been solid from the free throw line as well. He works hard during practices and games and motivates his team to do the same. His sense of humor and confident smile are a pleasure to be around. Dan has become one of our leaders, one of our go-to guys, and someone that we would not be the same without. Dan was nominated by Coach
This
Fitch.
is all.
Jags, come to our girls basketball team against Golden tonight at 7 p.m. in the Jungle.
The theme is neon for the girls' games tonight at 7 p.m. in the jungle. Be there. Also, tomorrow the boys play South Bend at 7 p.m. and play out with the good luck or come out to support. However, unfortunately, the fan bus is being canceled. That's our announcement. Have a great day.
That's too bad. You can all park and pack in my car. I'll take it. What does that mean?
Well, there's like
Safety,
differing
safety.
opinions between how like it is with seatbelts.
I'm a very safe driver. It'd be fun. It'd be one of those pack my little Honda accordion with and people.
You say Honda accordion?
Honda
That's what I heard.
Your one, Cyclophobia. What? Stacy.
Clowns are like dogs.
Clowns?
Yeah.
Did you watch that It movie?
No. Because they're scary.
Funny, it scared the bejesus.
No,
You
it's
thought it was funny?
It's so funny. It's not
No.
scary at
I
all.
wanted to sleep with my mommy after
It's so funny.
that. No, it's terrifying. I didn't get to 4. Sorry. Have a nice day.
We after school.
Well, where are I now? Maybe you should just have your homework done.
Well, listen. Okay, I was doing it, and then my mom was here, and I had to help her with groceries. So, and then it was dinner time, and then it was time for me to take care
Hi.
of it.
Mine wasn't late either.
Okay, I got it. I'll fix it. Thank you.
Okay. And then also, I'm going to be gone Friday and Monday for college visits.
Ooh.
No, I'm busy over spring break.
Oh, but you're not busy now during school year?
No. I'm reading.
No.
What is math?
Yeah, it's all the buildings always point to.
You say Monday.
Friday, Monday, yes.
Oh, and the only one good at is C.
Okay, there you go.
Thank you.
You're welcome. All right, stop it.